Okay, let's get started with today's session. Yesterday we looked at some of the subqueries, and I told you that we'll be covering correlated subquery today. So even before we start that subquery, let's say, for example, we want to find out who is earning the top salary. This can be done with a subquery. It's a single row subquery. So first of all, what we need to do is we need to find out what is the top salary, right? So by doing max of sal from EMP, this will tell us what is the maximum salary. And then we have to find out who is earning this salary, right? Select star from EMP where sal is equal to, you just put this whole query inside a subquery. So that's how the query looks like. And when I run this, it basically tells us who earns the maximum salary in the whole department, whole company, right? So now what if you want to figure out what is the maximum salary in who earns the maximum salary in each department? Okay, how do you do that? So basically what we have to do is, so every employee has a department number. For every employee's department number, we have to run a max salary in the inner subquery should run for every single employee's department number. And then we'll be able to figure out for every department who earns the maximum salary. So let's start explaining this correlated subquery, and then you'll be able to figure out. So first of all, I will say outside emp is, say for example, EO is the outside query. So I'm just writing it as, like, say for example, EO.sal. Now inside, what I'm going to do is where department number equals to EO.department number. Okay, so if you change this to change this little bit here, what happens is now if I run, you can see for every single department, you will see who earns the top salary in every department. So the way it works is basically this inner query is executed for every single employee it is processing on the outer query. So EO dot department number is actually coming from outside from here. So whatever the row it is processing outside, the department number is passed to the inside query. And based on that, it will run what is the maximum salary of that particular department. And if it is equal to the employee's salary, then it will bring out the record. Now, this is called correlated subquery because the inner query correlates some of the values, like say, for example, specifically this column. This is coming from the outside query. So it correlates the values from the outside query. So these are two queries in here. One is a subquery, one is the main query. So the inner query or the subquery takes the value from the outer query and runs inner query. So for every single row it is processing on the outer query, it will run the inner query for every single row it is processing from the outer query. Uh, it could be complicated to understand, but once you know this concept, like, you can refer to some values from the outer query inside the inner query. This is what is called correlated subquery. Let me know if you have any questions. Again, these are all based on different scenarios. Like, you need to actually have a scenario where where you will come across such requirements and you will design these queries accordingly. So far we did not talk about commit and rollback. Okay, so these are called transaction control language, commit and rollback. Let's talk about these things. which actually control what data is displayed to users. Now, let's say, for example, we can, let me see if I can open another session for the open a SQL worksheet. Okay. So here I connected as Scott user. So you can see here, select user from dual, and you can see who am I connected as, Scott. And even on the second one, select user from dual. I just opened two SQL windows where I'm connected as Scott user on both of them. Okay. But each user session is a unique session. Like whatever they do within their session, that is local to them. Meaning, let's say, for example, take a look at what tables we have for Scott user. And if you run this query, you can see there are a bunch of tables here. And also, let's say, for example, we'll do the same query, select star from tab in the second connection, second Scott user connection, and you will see that the same tables exist for uh, both Scott connections because tables are common to these users. What is not common is the session itself. So let's say, for example, let's take a look at what is in the, um, let's say, talk about phone book. Let's say select star from phone underscore book. Okay. So in this query, if you see, there are three rows in the phone book column, I mean table. And in the second window also, let me also note that session 2, and also let me run this phone book thing. And here I will say session 1. So we know which session we are talking about. Okay. Now phone book has three rows here. So let me say, for example, insert into phone book values. I'm going to insert three values. Let's say, for example, what is a person name? Person name is XYZ. What is the age of the person? Let's say 20. And what is the phone number of the person? Let's say this person has a fancy phone number. So let's say all ones. And then what is the location of the person? And let's say, for example, Utah is the location. Now, once I insert this row within this session, you can see that XYZ exists in the table. But when I go to the other table, other session, session two, even if I run this, oh, I think SQL developer is using the same session. Okay, this is not a good example to show then. Now what we'll do is we'll directly go to Oracle server here, and I'm going to connect to SQL plus Scott Tiger, and then clear screen. I will say select star from phone underscore book. Okay, now you don't see that XYZ record. Okay, so let me explain first of all what's happening here. I have a session open with SQL developer. We have this phone book table. It had only three records. We inserted a new record using this insert statement. And then I went to this black and white SQL plus screen, same database, same user, same phone book table, but XYZ record is not displayed here. Okay. What is happening is your whatever inserts you do, whatever changes you do, even you do updates. Let's say, for example, I will change the age of everybody in this table. Let's say update phone book set age equal to 50 for all the users. I will just set it to 50 in the session 1. 4 rows got updated. Let me look at the output. You can see the age is updated to 50. And this is again within the SQL developer session. Let me go back to SQL plus session and run this select start from again. You still don't see the XYZ record and you still see the age which is old. Okay. Now why this is happening is because whatever changes you do are local to your session and they are not published until you actually say commit or rollback. Okay, so let's say for example if I do a commit now, let me run a commit, and what is happening is now you're sure that all your changes are good, so then you're doing a commit. By doing a commit, you're actually whatever changes you did, you're making them permanent. So let's look at the session here. Everything looks okay from the SQL developer. Now let's go back to the other session and run the same command. Now you start seeing all the changes, like say for example this XYZ person and also age got updated. Okay, so let us say let us take an example of what we'll do here is now using this SQL plus, I will say update phone book set location equal to. Let me just make sure that location column is called location. Yes, it is called location. I will set the location to Boston for everybody. Okay. Now I will do a select star from phone book. And what you see here is the location got updated for everybody. Now let's go back to the other window here and run the same query again. And you see these are still showing the old values. Okay. Because as I explained, the whatever changes you did are local to this session. They're not committed or they're not permanently saved until you do a commit, like say commit. Okay. Now, what happened is I'm not going to run this commit. What happened here is by mistake, I set the location Boston for everybody. But what I was going to do was actually XYZ is the person who moved to Boston. Everything else should be in its old values. So I know that this happened by mistake. So now what I'll do is I don't want to save any of these changes. I will say roll back. Don't save these changes. Okay. Now what is going to happen is now if you query this table, it will show you the old values. Okay. And if you go back here, there is no difference, like it will show you the regular old values. Let's go back here. Now I realize that I need a where clause. So I will say where person underscore name is equal to XYZ. Okay, only for that person. And also you can notice here that only one row got updated, not all rows. Like here it was all rows updated, like all 4 rows. So let's run this again. And what I want to show you is only for XYZ, I changed the location to Boston. And again, go back here. If you run this query, it still shows Utah because I have not committed these changes. Okay. So now let's say, for example, we look at everything. We say, okay, this is a good update. Maybe Boston should be in uppercase. So I will do an update again. So let me do this update. Boston should be in uppercase. So whatever changes I have to do, I will finish them, make sure they look good, and then I will do a commit. Okay. So whenever I commit, all the changes done so far since the beginning or the previous commit, everything should be permanently written. Okay, so let me run this here. I want to show you what happens here. So you can see now the value is permanent. Okay, so what can you roll back and what you cannot roll back? Okay, so let's discuss about what is the length of this rollback and commit. So let's say, for example, we will say, okay, start the session. Okay, do some updates, inserts, commit. Okay, then we we close the session, or we can do whatever we want. We'll just leave it there, and we come back tomorrow. Come back later, whenever the later is. Okay, and also I will just comment these things so we know. Okay, now I just say rollback. Now in this session, when you did a comeback later in this session, the first thing you're doing is a rollback. You didn't do any changes, so there are no updates, inserts, or deletes. So there is nothing to roll back. Okay. Also remember that when you do a rollback, it will roll back until the previous commit or until the previous rollback. Same way, when you do a commit, it is going to commit about all the changes done within that session until commit. So once you commit, you cannot go back. You cannot say roll back the commit. Okay. So is that clear? Once you commit, you save the changes permanently. You cannot roll back the changes which you did because you already issued a commit. Okay. So this is very important because your database can be shared, and there can be like 100 users using it at the same time, and all of them need to have a consistent view of their data. So this is a very important concept where it is commit and rollback comes as a transaction control. And so that's what we discussed right now. This is called TCL. Let me put it here. The commit and rollback are TCL, which is transaction control language. Okay. We'll also talk about something called DCL, and DCL is nothing but data control language. Okay. So SQL has all these pieces called TCL, DCL, DML, DDL. So right now we are going to talk about DCL, data control language. Now what happens is in the data control language, we are going to tell who can see our data. And the two commands here are grant and revoke. This is mainly related to the permissions. Okay. So first of all, in the Scott user, there are bunch of tables. Okay. So what we'll do here is let's go to the system user. I'm going to go to the super user like a DBA user. Okay, let me disconnect. And what we'll do is we'll create other users. So because we need to have some users so that we can play with them. Create username. This is the syntax. DBS, your administrator will do this for you if there are new users. So you just create a user. Your DBA will create the users generally. So let's say, for example, user one, okay, identified by, you have to specify some password. Let's say password, okay, whatever password you want to specify. And then what you do is, let's say, for example, we'll create bunch of users. Let's say second user and third user, user 1, 2, 3, and all of them have same password, which is not suitable for production. I'm just doing it for your test here locally. Okay. And if you look at the output, it says user 1 created, user 2 created, user 3 created. Okay. So now let's switch to this here. This is the SQL. I will say, for example, SQL plus, okay, user 1 and password is password. So like that. And you can see here, it says there is error. Okay. What it says is user 1 lacks create session privilege, login denied. Now, Oracle RDBMS is very powerful in the sense it will protect your data well. Unauthorized users cannot log in, and they cannot say select star from your table because they cannot even log in. without proper privileges. So how is it protecting is there are something called privileges which you need to grant. I just created users. I did not grant them any privileges. So let's go grant some privileges to these three users. Let's say, for example, grant okay, connect comma resource to user 1, user 2, and user 3. I will grant it to all three users. So by doing that, it is going to do a grant succeeded. Now, what I did there is, like your DBA will know, I just allow the user to connect. So you can see the first time user is not able to connect, but after granting privileges, that user 1 is able to connect. So now, right now, I'm connected to this database as user 1. And how can you check? Select user from dual will show you who is the user connected right now. Okay. So this is how you check which user you're connected as. So now I told you that the Scott user has several tables. So let's say, for example, select star from, you can do a scott.emp and let's see what it says. It says table or view does not exist. Actually, that table exists, right? If you go back to the other window here, let's say go to the Scott user. Let me just remove all this. We don't need any of this right now. Let's say scott.emp. It is the same user. So when I run this, it shows the output. Okay. Or let's say, for example, dept. It shows the output. That means these tables exist. But from another user, user 1, like here, I'm going to say select star from scott.dept. It says table or view does not exist because this user does not have any permission to see the table which is owned by some other user. Okay. Right now I'm logged in as user 1 here. So what we have to do is we have to grant some privileges so this user can see the data. And you can decide how much you want to grant. Let's say, for example, we'll say grant select, okay, on dept to user 1. So this is a very straightforward syntax. First of all, you're telling what to grant select privilege on which table to which user. Okay, so that's how it goes. So when I run this, it is going to grant this privilege to the other user now. Now let's go back to the user 1 and do the same select. Now I'm able to see the data. Okay. So if you try to see employee table, you will still not see it because you need a special privilege granted to you. Unless you get that privilege, you cannot see that data. Okay. Now let me show you something as user 1. I'm going to insert into scott.dept table values. There are three values you need to provide. First of all, what is the department number? What is the department name, DPT name, and let's say what is the location. So DEPT location, something you're going to provide three values. Now here you can clearly see it says insufficient privileges. Even though you have select privilege, like you can select data from the table, but you cannot insert because you don't have privileges. So it is a very fine-grained control on what the other user can do on your tables. Okay. So if you want other users to also insert data, then you have to give them insert privilege. Okay. So what you're saying here is grant select and insert on DEPT to user 1. Okay. So if I run this, you're granting another extra privilege called insert. Now I'll be able to do an insert. So let's see insert. One row got created and you can do a select star from DEPT and you can see what you inserted here. Okay. So This is how you actually grant privileges. And let's say, for example, now I am going to commit this change. Okay. And suddenly you come back and say select star from scott.dept. You notice that somebody did a mischief, like they're inserting invalid rows. So this is a invalid data. So then you realize who did it because you know what privileges you granted to other users. What you'll say, okay, I know that you cannot insert, you should not insert, you can only select. I'm going to take your granted privilege back. So revoke, okay, insert. So how it goes, like, when you granted, you know what is the syntax, right? Grant privilege on what is the table to which user. So same thing you're going to do, revoke, insert on DEPT from user one. Okay, so if you see, this is very straightforward English. So you're revoking the insert privilege, but you're leaving the select privilege on. Meaning now if I do a select star from DEPT, I can see that I can insert. I can do the insert, but I can do the select, but I cannot do the insert again. So let's say, for example, I'll change this department number to 70 and do an insert. It says insufficient privileges. So you can grant privileges and you can take away those privileges. Okay. So now let me show you how you can remove the select privilege also. Like you granted a privilege select. So let's take it away. Now let's say, for example, you want to revoke select privilege. Okay. By running this, you revoke the select privilege from select, revoke select on DEPT from user. So this is how you revoke privileges. So let's go back here and say select star from scott.dept. Now it went back to saying table or view does not exist. So why does it say table or view does not exist? Because it doesn't even tell you that the table is valid. Meaning, if you look at how hackers work, hackers first try to figure out if that exists. If it exists, then they will try to hack into it. So here, Oracle is not even telling you that it is existing. All it says is simply it says it does not exist or table does not exist. So hacker may be thinking, oh, there is no table, so there is nothing to hack. So that's how it works. Now, what I want to show you in this example, what we did was, you see how we granted a select privilege on the table and he can see all the data. So let's create a scenario where let's say, for example, we are going to grant a select privilege, okay, on EMP table to user one. Okay, so let's run that. It grants the privilege. Now let's go back to the other table, other SQL session, and say select star from EMP. Okay, sorry, not EMP. You have to specify scott.emp because we are querying it from somewhere else. Now here you can see all the data came back, and let me clear screen. What I will do is I will select only the employee name and salary. Okay. So now I'm able to see the salary. What should happen is actually we don't want ever to show our salaries, employee salaries to other users. So we should protect this column. We should not give privileges to see this. Now, what is happening right now is everybody, like whoever has this privilege of seeing, will be able to see the salary column. Now, the reason it happens is because the grant privilege works as select on table, but it doesn't tell what columns you can select. It just gives the full privilege on the table. Okay. So how do we protect the salary column? That is not going to happen this way. What we have to do is actually we have to revoke the privilege and we have to create a view. Instead of showing the whole thing, we'll create a view. So let's revoke this privilege and go back here to check if we are able to run. So you can see we don't have privilege. So it just simply says table does not exist. Okay. So now what we'll do, we'll ignore all this. What we'll do as a Scott user is we will create a view. Okay. So this is first time we are talking about other than tables. So view is nothing but a stored query. Okay. Now what is the query you want to grant privilege on? Like let's say for example, how do we create a view? First of all, let's look at what is the use of a view. Okay. So let's say for example, select star from employee. I can say for example, where department number in, let's say a specific department. There are two departments I want to pick. Let's say 20 and 40. I don't know if 40 has any employees. So let's say for example 20 and 30. Okay. So this should have some employees. So you can see there are other 4 employees missing in this list. Okay, because they don't belong to these departments. At the same time, I want to say ename, comma job, comma hire date. Okay, these are the only 3 columns I would like to share. So I don't want to see all the data all the time. I just want to see this much data. Okay. So in this case, you can create a view, and how do you do that is create view name. Okay, view name generally it's a good practice to start with v underscore. So it simply tells you that it is a view. And let's say for example v underscore emp. Okay, as this is the syntax. So what you're doing is create view. This is view name as you provide a select statement. Okay, a query. So now what happens is if you run this, oh, see, I don't even have privilege for the Scott user does not even have privilege to create views. So I have to grant some privileges. Let's say, for example, grant create view to Scott. Let's do that. So now let me go back and create view. So I need more privileges, and you can see here view v underscore emp created. Okay. Now if you do a select star from tab, you can see this view in the output. Okay. So this is the view, and it is telling you that it is a view. Now let's do a select star from view, select star from v underscore emp. Okay. So this is a query you run as if this is a table, but actually it is a view. Okay. So you can see here view is returning only 3 columns and only returning certain amount of rows from like whatever is the rows. Okay. So this is how you create a view. And now what you can do is you can grant privilege, grant select on v underscore emp to user 1. So that way this user can now look at the data in this view. Okay. So remember before I was telling you a scenario where we don't want to show the salary. So I don't have salary now in this particular view. And you will tell user 1, hey, now you can select from v underscore emp, and this user will start seeing only 3 columns. So salary is well protected now, and he will not be able to run a select on emp table because that um, it just tells you don't have privileges. So it just tells you there is no table like that. But now we saw how we protect the uh, original table and also protect some columns from displaying to the other user. Okay. Now what happens if a user tries to insert, let's say for example, okay, let me ignore that. What we'll do is we can create these views with extra stuff. Let's say for example, I'll show you one more way of creating this view. So let's say, for example, v underscore emp2 is another view where I'm going to specify exactly same thing, but I will say with read only is the is a read only view. Okay, meaning users cannot do any changes to the data inside this view anymore. Okay, let me explain how it works. So now we have select star from v underscore emp. Okay, and then we have select star from v underscore emp2, and then obviously we have our base table. Okay, so let's look at the base table first. You see this data, and then let's say, for example, you look at the first view. You see everybody is hired in 1981 or 82 or 83 time, and also all the jobs and then all these things. What you can do now, because you as a user, you can do update v underscore emp set. Okay, set hire date equal to sys date. That means everybody is hired today if you run this. So if you do that, you see how 11 rows got updated, and you can look at your base table. Base table also shows that some of the rows are got updated to 2016. You can see this is today's date. Okay, it only updated 11 rows because that view is only providing data for these two departments. Okay, so only that data got updated. So that means if you have a view, you can do some updates and it will affect the base table, meaning whatever the original data, it gets updated. Because view itself is not storing any data, it just goes to the main table and does whatever updates you have to do. But let's say this is invalid, right? You know that hire date cannot be changed. Like, it was, they were hired in 1980 or 81. This is an invalid update. So let me do a rollback. And you know that, whatever changes you did in this session, because you did not commit yet, you can run a rollback and it says rollback complete. Let me verify by querying the original table, and you can see all the dates are back to original. Now let's do the same thing, but on the second view. Okay, we'll do an update on the second view, and now it shows an error because it tells you you cannot do any DML operation on a read-only view. The reason is we created this view using with read-only condition. So what people do is in a production scenario, what they do is, let's say, for example, if you have to share your data with some other user or some other department, you create a view, you restrict all the things you don't want to show them, you just remove all those columns from the view and make it a read only, and then grant select only privilege to that user. So that way you have put all the restrictions you need. You take only specific columns and then put the read-only privilege. I mean read-only condition on that. So the view cannot be updated. That means they can never corrupt your base data like original table. Okay. So this is how you create a view. And obviously to drop this view, you will just do drop view name. Okay. So let me show you how you drop. Select star from tab will show you what views and tables you have. And you can see, let's say, for example, we have v underscore emp, which we no longer need. You will just say drop view v underscore emp, and it will disappear. Okay, view got dropped. So let's look at the tab again. Let me run this, and you can see that v underscore emp is gone. And you can do a describe v underscore emp2, and you will see that it looks like a table. Actually, it is not a table. It is just a view, and you can tell it is a view because of this. Okay. tells you that v underscore emp2 is a view. Cool. Okay, there is one more interesting thing is called sequence. So let's talk about sequences. So first of all, what are sequences? Is you need something like a number generator. Like every time you ask it, um, it will generate the next value. I mean, it will generate the next possible value. So sequence is a number of, I mean, sequences and is a sequence of numbers, and you can pick the next value. So sequence will maintain what is the current value and the next value. So how do you create a sequence? First of all, create sequence. And I'm not sure if we have privilege to do this. SEQ is good naming convention. And then you can call it, let's say, employee numbers. Okay. So whatever name you want. Okay. Start with 1, increment by 2. Okay. Start with, let's just start with 10, increment by 5, and then no max value. Okay. So there is no maximum value, and I created this sequence. So let me explain. It starts with 10. The first value it will generate is 10, and it will then increment by 5 every time I ask for next value. Okay. So first of all, let's do a select star from tab again, just to see if this sequence exists. And let's see, there is, okay, sequences are not displayed in the tab, but let's say it will be displayed in user underscore sequences like that. Okay. So now you can see this sequence exists. Minimum value is 1 and maximum value is this, increment by, and last number generated, whatever it has to keep. Okay. This is some data dictionary. Now, how you'll use the sequence is you will say select next underscore val. Okay. So you will need to give the sequence number. You will do a sequence number dot next underscore next val from dual. Okay. So the way you query this is you will say what is the sequence name dot next val from dual. Okay. Now, if I run this again, it increments by 5. You see how it started with 10, increments by 5 every time you run that. Now, let's say, for example, we'll go back and run something else and then come back and say, hey, what is the current value of this sequence? Because I want to know current value. I don't want to generate a next value. Okay. So if I run this, now you can see the current value is 35. Okay. So how is this used in real scenario? Let's say, for example, let me generate a few more. Actually, let's not bother to generate. What we'll do is, let's say, for example, select star from tab. I want to see, we had one table where we had like say customers, this one. Okay. So let's say, for example, I want to use this as a customer number. Select star from customers. Okay, I think so spelling is good. Okay, now let's say for example I want to insert into customers. Okay, and I will say values. Here I can say what is the sequence current next value, comma, I will say name is something, email ID is null because I don't know the email ID, age is 30. Okay, I'm going to run this. Hopefully there is no constraint. So it inserted data. So let's look at the data. You can see here it generated a new value. And you can keep on running this because every time it runs, it will generate a next value. And let's look at the data. Now you can see the data has been generated. So this is used as a primary key generator. Sequences are very important, very useful. And in Oracle, sequences generate unique values. So I think that's all for today. We'll stop it here. We'll continue tomorrow. We'll take a look at other things like synonyms and indexes. Okay, thank you very much.